The Venera program was one of the most ambitious and groundbreaking endeavors in the history of space exploration. Initiated by the Soviet Union, the program spanned from 1961 to 1984 and aimed to explore and study Venus, the second planet from the Sun and often referred to as Earth's twin. However, as we'll discover, Venus is anything but a twin in terms of its environment. Venus, named after the Roman goddess of love and beauty, has fascinated humans for centuries. Its brilliant shine in the night sky has inspired countless myths and legends. But beneath its thick clouds lies a world of extreme conditions that challenge our understanding of planetary science. Unlike Earth, Venus has a surface temperature hot enough to melt lead, crushing atmospheric pressure, and clouds of sulfuric acid. Understanding such a hostile environment was no small feat and required remarkable innovation and persistence. The Soviet Union embarked on the Venera program with the ambitious goal of not only reaching Venus but also landing on its surface and sending back data. This was during the height of the space race, a period of intense competition between the Soviet Union and the United States. Each nation sought to demonstrate its technological and scientific prowess by achieving new milestones in space exploration. The Venera missions were part of a broader Soviet strategy to explore the inner planets of our solar system. Unlike the United States, which focused primarily on the Moon and later Mars, the Soviet Union set its sights on Venus, recognizing the scientific value of studying a planet so similar in size and composition to Earth, yet so different in its conditions. The Venera program would ultimately consist of over a dozen missions, each building on the successes and lessons learned from its predecessors. Early missions in the Venera series were fraught with challenges. Spacecraft had to be designed to survive the harsh conditions of launch, the vacuum of space, and the descent through Venus's dense atmosphere. These early attempts provided valuable experience and data, even when they didn't achieve their primary objectives. Each mission brought the Soviet scientists and engineers one step closer to success. As we delve into the Venera program, we'll explore the technological innovations, scientific discoveries, and sheer determination that defined this extraordinary chapter in space exploration. The early missions of the Venera program were a series of trials and tribulations, marked by both frustration and invaluable learning experiences. The journey began in 1961 with Venera 1, the Soviet Union's first attempt to reach Venus. Unfortunately, contact was lost en route, and the spacecraft drifted silently through space, never fulfilling its mission. Despite this setback, the Soviet scientists and engineers pressed on. They knew that failure was an inherent part of pioneering uncharted territories. The next few missions, Venera 2 and Venera 3, launched in 1965, also faced significant challenges. Venera 2 failed due to overheating, while Venera 3, although it became the first human-made object to reach another planet, lost contact before it could transmit any data back to Earth. These early failures were disheartening but provided crucial lessons. Each mission revealed new obstacles, ranging from technical malfunctions to the unpredictable harshness of space travel, that needed to be overcome. The engineers went back to the drawing board, making incremental improvements and adjustments based on the data and experiences gathered from each mission. In 1967, Venera 4 marked a significant breakthrough. It was the first spacecraft to successfully transmit data back to Earth from within Venus's atmosphere. Venera 4's instruments revealed that Venus's atmosphere was composed mainly of carbon dioxide, with very high pressure and temperatures, and clouds of sulfuric acid. This was a pivotal moment, proving that it was possible to send a spacecraft into Venus's atmosphere and receive valuable scientific data. The following years saw continued efforts to refine the technology and strategies. Venera 5 and Venera 6, launched in 1969, provided more detailed atmospheric data but still did not survive the descent to the surface. However, these missions confirmed the extreme conditions on Venus, emphasizing the need for robust engineering solutions to withstand the planet's hostile environment. It wasn't until 1970 that the Soviets achieved a major milestone with Venera 7. This mission made history by becoming the first spacecraft to land on another planet and transmit data back to Earth. Despite a rough landing that left it tilted and partially damaged, Venera 7 managed to send data for 23 minutes, providing direct measurements of surface conditions. This groundbreaking achievement provided the first direct measurements of Venus's surface conditions, confirming the planet's scorching temperatures and crushing atmospheric pressure. The data indicated a surface temperature of approximately 475 degrees Celsius and an atmospheric pressure 92 times greater than that of Earth, painting a vivid picture of Venus's harsh environment. Building on these successes, the Venera 9 and 10 missions in 1975 took things a step further by sending back the first images of Venus's surface. These missions utilized advanced camera technology capable of withstanding the intense conditions on Venus. The images revealed a rocky, desolate landscape, marked by large boulders and flat plains. For the first time, humanity had a glimpse of the surface of another planet, thanks to the resilience and ingenuity of the Venera Program. In 1982, the Venera 13 and 14 missions delivered some of the most detailed data yet. These spacecraft were equipped with a suite of scientific instruments designed to analyze the chemical composition of Venus's soil and atmosphere. Venera 13, in particular, set a record by transmitting data for 127 minutes before succumbing to the extreme conditions. It sent back the first color images of Venus's surface, providing a more detailed and accurate representation of the landscape. The analysis of soil samples revealed a composition similar to basaltic rocks on Earth, offering insights into the geological history of Venus. These missions also captured sounds from the planet's surface, adding another layer of sensory data. The microphones on Venera 13 recorded the eerie sounds of the Venusian wind, giving scientists a more comprehensive understanding of the planet's dynamic atmosphere. Each of these achievements represented a significant leap forward in our knowledge of Venus. The Venera missions not only demonstrated the feasibility of landing on and studying another planet but also provided a wealth of scientific data that continues to inform and inspire planetary science today. They showcased the Soviet Union's capability to design and execute complex interplanetary missions, paving the way for future exploration of our solar system. The scientific discoveries made by the Venera Program were nothing short of revolutionary, providing a comprehensive understanding of Venus's extreme environment. One of the most significant findings was the composition of Venus's atmosphere. Through the data sent back by Venera 4 and subsequent missions, scientists learned that Venus's atmosphere is predominantly carbon dioxide, accounting for over 96% of its composition. This discovery was crucial in explaining the planet's runaway greenhouse effect, which leads to surface temperatures averaging around 475 degrees Celsius. The Venera missions also measured the atmospheric pressure on Venus, revealing it to be about 92 times greater than Earth's at sea level. This intense pressure is equivalent to being nearly a kilometer underwater on Earth. The data indicated that any spacecraft landing on Venus must withstand pressures that would crush most materials, posing a significant engineering challenge. The cloud layers of Venus, composed mainly of sulfuric acid droplets, were another critical discovery. These clouds create a thick, reflective layer that contributes to Venus's brightness as seen from Earth, but also pose a severe hazard to spacecraft. The Venera missions provided detailed information on the cloud structure and composition, enhancing our understanding of Venusian weather patterns and atmospheric dynamics. Temperature measurements from the Venera landers confirmed that Venus is the hottest planet in our solar system. The surface temperature remains fairly uniform at around 475 degrees Celsius, regardless of location or time of day. This uniformity is due to the dense atmosphere that efficiently distributes heat around the planet. The missions also recorded the rate of atmospheric circulation, discovering that Venus experiences superrotation, where the atmosphere circulates much faster than the planet itself rotates. Another groundbreaking discovery was the chemical composition of Venus's surface. Venera 13 and 14, equipped with advanced analytical instruments, revealed that the Venusian rocks are similar to basalt, indicating volcanic activity. This finding suggests that Venus has a geologically active history, with volcanic processes playing a significant role in shaping its surface. The soil analysis conducted by these missions provided crucial insights into the planet's geological processes and surface composition. The Venera missions also studied the planet's wind patterns and acoustic environment. Venera 13 recorded the sound of the wind on Venus, giving scientists a direct auditory experience of the planet's harsh environment. The data on wind speeds and patterns helped in understanding the dynamic weather systems on Venus, which are driven by the planet's rapid atmospheric rotation. These scientific discoveries were pivotal in reshaping our understanding of Venus. Prior to the Venera program, Venus was often thought to be similar to Earth, possibly even harboring life. The harsh realities uncovered by the Venera missions, however, painted a different picture, one of a hellish world with extreme temperatures, crushing pressures, and acidic clouds. This wealth of data not only advanced our knowledge of Venus, but also provided comparative insights for studying other planetary atmospheres and climates, including Earth's. The technological innovations developed for the Venera program were groundbreaking and set new standards for space exploration. Designing spacecraft to survive Venus's extreme conditions required unprecedented engineering solutions and creative problem-solving. One of the most significant challenges was constructing a spacecraft capable of withstanding the intense heat and pressure on Venus's surface. To handle the intense thermal environment, the landers were equipped with advanced thermal control systems. These included insulation layers and cooling mechanisms designed to dissipate heat and keep the internal electronics at operational temperatures for as long as possible. The success of these systems was evident in missions like Venera 13, which transmitted data for an impressive 127 minutes before succumbing to the extreme conditions. Communication was another critical aspect of the Venera missions. The thick atmosphere of Venus posed significant challenges for radio transmission. Engineers developed powerful transmitters and robust antennas to ensure signals could penetrate the dense atmosphere and reach Earth. The Venera spacecraft utilized a combination of high-gain and low-gain antennas to maintain communication throughout their descent and landing. One of the most innovative features of the Venera landers was their ability to conduct scientific experiments and transmit data under harsh conditions. Each lander was equipped with a suite of scientific instruments, including thermometers, barometers, anemometers, and spectrometers. These instruments were designed to be both durable and highly accurate, providing valuable data on Venus's atmospheric composition, surface pressure, temperature, and wind patterns. The landers also featured panoramic cameras capable of withstanding Venus's harsh environment. These cameras captured the first images of the Venusian surface, providing humanity with a direct visual glimpse of another planet's landscape. The cameras used quartz lenses, which could endure high temperatures without degrading, and were mounted on rotating platforms to capture a 360-degree view of the terrain. Parachute systems played a crucial role in ensuring the lander's safe descent through Venus's thick atmosphere. Early missions utilized standard parachutes, but these often failed due to the extreme conditions. Later missions incorporated more robust designs with materials capable of withstanding the high temperatures and pressures encountered during descent. Some landers also used braking parachutes and air brakes to slow their descent and ensure a controlled landing. In addition to the landers, the Venera orbiters provided valuable data about Venus's atmosphere and surface from above. These orbiters were equipped with radar systems to map the planet's surface through its thick cloud cover. This radar data revealed detailed topographical features and contributed to our understanding of Venus's geological history and structure. The innovations developed for the Venera program extended beyond Venus exploration, influencing subsequent missions to other planets and moons. The technologies and engineering solutions pioneered by the Soviet engineers provided a foundation for future space exploration, demonstrating the importance of resilience and adaptability in the face of extreme challenges. The technological achievements of the Venera program showcase the ingenuity and determination required to explore our solar system's most hostile environments. These innovations not only enabled the successful exploration of Venus but also advanced our overall capabilities in space science and engineering, leaving a lasting legacy in the field of planetary exploration. The legacy of the Venera program is profound, extending far beyond its immediate scientific discoveries about Venus. The program's impact on space exploration, planetary science, and international collaboration continues to resonate today. Let's explore how the Venera missions have shaped our understanding of the cosmos and influenced future endeavors. Firstly, the Venera program revolutionized our knowledge of Venus, transforming it from a mysterious celestial body to a well-characterized planet. Before Venera, many speculated that Venus might have Earth-like conditions or even harbor life. The data returned by the Venera landers dispelled these notions, revealing a world of extreme temperatures, crushing pressures, and a toxic atmosphere. This comprehensive understanding of Venus's hostile environment has been crucial for comparative planetology, helping scientists understand why Venus and Earth, despite their similarities, evolved so differently. The engineering feats accomplished by the Venera mission set new standards for spacecraft design. The ability to construct landers capable of withstanding such extreme conditions demonstrated the Soviet Union's advanced engineering capabilities. These technological advancements have influenced the design of subsequent spacecraft for exploring other hostile environments in our solar system, such as Mars, Jupiter's moon Europa, and Saturn's moon Titan. The data and experiences from the Venera missions provided valuable insights that have been applied to other planetary missions. For instance, the techniques developed to study Venus's atmosphere and surface have informed the design of instruments and mission planning for Mars rovers and orbiters. The success of the Venera program proved the feasibility of landing on and transmitting data from other planets, paving the way for more ambitious missions in the future. Moreover, the Venera missions underscored the importance of international collaboration in space exploration. While the Soviet Union conducted these missions independently during the Cold War, the findings from the Venera program have been shared with the global scientific community. This exchange of knowledge has fostered a spirit of cooperation and mutual benefit, leading to collaborative efforts like the International Space Station and joint missions such as the European Space Agency's Venus Express. The Venera program also left an indelible mark on public imagination and inspired a generation of scientists and engineers. The images and data from Venus captured the world's attention, highlighting the potential for human ingenuity to overcome seemingly insurmountable challenges. The program demonstrated that even the most inhospitable environments could be explored with determination and innovation. In recent years, there has been a resurgence of interest in Venus, partly fueled by the foundational work of the Venera program. Space agencies like NASA and the European Space Agency are planning new missions to Venus, such as NASA's Veritas and Da Vinci Plus missions, and the Envision mission. These upcoming missions aim to build on the legacy of Venera by further investigating Venus's geology, atmosphere, and potential for past habitability. The discoveries made by the Venera program continue to guide these new missions, illustrating the program's lasting influence. Furthermore, the Venera program's legacy is evident in the broader context of planetary exploration. The program demonstrated the value of robotic exploration, setting the stage for the sophisticated rovers and landers that now explore Mars and other celestial bodies. The pioneering spirit and technological breakthroughs of the Venera missions remain a source of inspiration and a benchmark for future exploration endeavors. In summary, the Venera program's legacy is multifaceted, encompassing scientific advancements, technological innovations, and a lasting impact on the field of space exploration. It stands as a testament to human curiosity and the relentless pursuit of knowledge, reminding us of the incredible achievements possible when we dare to explore the unknown. Looking ahead, the future of Venus exploration is brimming with exciting possibilities and renewed interest. The groundbreaking achievements of the Venera program laid a solid foundation, and now, several new missions are poised to build on this legacy, promising to unveil even more about our enigmatic neighbor. One of the most anticipated missions is NASA's Veritas, set to launch in the late 2020s. Veritas aims to map Venus's surface in high resolution, using advanced radar systems to peer through its thick clouds. This mission will provide detailed topographic data, helping scientists understand the planet's geologic history and tectonic activity. By studying surface deformation and volcanic features, Veritas will shed light on whether Venus is still geologically active. Another exciting mission from NASA is Da Vinci Plus. Scheduled to launch around the same time as Veritas, Da Vinci Plus will focus on Venus's atmosphere. It will descend through the atmosphere, taking measurements of its composition, structure, and dynamics. This mission aims to understand the chemical processes at play and how Venus's atmosphere has evolved over time. One of its key goals is to determine if Venus ever had oceans, which could provide clues about its past habitability and why it diverged so drastically from Earth. The European Space Agency is also planning a mission called Envision, slated for the 2030s. Envision will complement NASA's efforts by focusing on both the atmosphere and surface. Equipped with a suite of high-tech instruments, Envision will analyze Venus's surface composition, study its atmospheric gases, and investigate the planet's internal structure. This mission will provide a holistic view of Venus, integrating data from previous missions and offering new insights into the planet's geological and climatic history. In addition to these major missions, there are also ambitious proposals and concepts being explored. For example, the idea of deploying aerial platforms such as balloons or drones to study Venus's atmosphere at different altitudes is gaining traction. These platforms could float above the surface, conducting long-term studies of atmospheric composition, weather patterns, and solar radiation. Such innovative approaches could revolutionize our understanding of Venus and pave the way for even more detailed exploration in the future. One of the most intriguing questions driving future Venus exploration is the potential for past or present life. Recent studies have suggested the possible presence of phosphine gas in Venus's clouds, a potential biosignature. While this finding is still debated, it has reignited interest in searching for life in Venus's upper atmosphere, where conditions are less extreme. Future missions might include instruments specifically designed to detect organic molecules or other signs of microbial life. The renewed interest in Venus is not just scientific, it's also strategic. By comparing Venus with Earth, scientists can develop better models for predicting the climates of Earth-like exoplanets, enhancing our search for habitable worlds beyond our solar system. In summary, the future of Venus exploration is set to be transformative. With advanced technology and a wealth of scientific objectives, upcoming missions will delve deeper into Venus's mysteries than ever before. The legacy of the Venera program continues to inspire and guide these efforts, reminding us of the incredible potential of planetary exploration. As we look to the stars, Venus remains a tantalizing target, promising to reveal secrets that could reshape our understanding of planetary science and the possibilities of life in the universe. Thank you for joining us on this journey through the Venera program. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating space exploration content. Leave a comment below with your thoughts on the Venera program or any questions you have about Venus. Until next time, keep looking up at the stars.